So who has made some progress? Dylan, Steven, can you share the screen?
I can, yeah.
Okay, let's see your exponential fit.
Okay.
That looks like the linear
This is the
um
exponential fit.
what? This I don't believe you. This looks too good to be true. So this thing here is like a perfect, yeah, interesting. Go to the exponential to the logarithmic. So it seems that there is more agreement here. Like if your subset of data was just that subset,
Yeah,
this would be a really good fit, you know.
right.
And then when you go to the exponential scale, then you see that there is this perfect agreement right there, you know. I think
Right.
also if your first data point was around here, like around the 20th,
Right.
then the model would try to take care, like, you know, of all those points there. So there is a discrepancy, but all that is subject to how many points you use and where do you start. Now, so that parameter r hat, is the slope, right, of the linear model. And what's the value of r hat?
Um,
Um, Seems here that is this, right? 0.16.
yeah.
So what's the value of the doubling time? Type in the console tau.
Okay.
Hit enter.
4.16.
So if that what would that tell you
It doubles every 4 days.
for Arizona with those points?
Right. Okay. So it wouldn't be 4 days.
So in fact, you could do what I just told you, right? Maybe I don't know in the time we have left, but you could create another CSV file that has fewer points because it starts, you know, right here. And then you could redo this calculation. And so you have right now that R is 0.16, and then maybe this is R1, and then tau 1 is like 4 days. And if you use another data set, you're gonna get a different R and a different tau, you know, and this could be part of the exploration. You say, hey, look, this is, yeah, we're computing here the doubling time, but this is quite sensitive to if we change the number of points. It depends of where you start measuring and what points you bring and what points you throw away, you know, and then that's going
Right.
to give you a different estimate for the doubling time.
Okay.
You would expect that what I mean, can you see in that being kind of true here? Like, if it doubles every 4 days, you still have a lot of days here, right? So between 20 and 40, that's 20 days. That's like a month.
Hmm.
So between 20 and 40, you have 20. I don't know if I'm good about this. So 20 divided by 4. So you should see that doubling 5 times.
Okay. Yeah.
Is that true? Like, or maybe where is the Excel file or the data? Can you uh, okay, that's the data, right?
Yeah.
And where do you see that feature that every 4 days it doubles?
I mean, you could just really click any 4 points, right?
Right. So let's see. Is the uh-huh.
So yeah.
13 to 28. That looks like what's the next? 40, 28 to whatever.
Oh, 28. Yeah. Oh,
Well, maybe you start with 47. 47 and then more or less, right? It's not a perfect double, but
no,
from
it's not.
47 to 153. And now if you start at 234 and go 4 steps.
They're
Um,
kind of off.
yeah, but remember, it's not I mean, there are points. So it kind of, it gives you an idea, right? So yeah, actually they're more than doubling there. So
Right.
when you say that is 4 days, that is an estimate, and as an estimate is not perfect. See
Yeah.
what I mean?
Yep.
So, but it's not that far from what you observe there. That's the point of this doubling times, and your other data sets are gonna have different values, right? Okay, so